Good morning. Testing 1, 2. All right, good. Okay, so thought this morning we could keep going with my little collections library, data structures and stuff. As you can see, I have implemented a simple queue and stack, generic queue and generic stack collection. Just the basics. Peek, pop, push for stack, and a queue I've got DQ, NQ, and peek. And it's they both extend my abstract collection class, which has already a few methods such as clear to remove everything, has, which is the equivalent to contains in different implementations, just tests if a specific value or object is in the collection, is empty, and remove. Also size and iterator, so that we can use a for of loop on it. So there you go. Now I'm debating what the next let me lower the volume a little bit. Okay. For the music. Like that, I think should be fine. Okay. So yeah, I'm debating what the next data structure collection is going to be. So for inspiration, I'm looking at the .NET C# collections library. And what do we have here? Dictionary. Let's see, dictionary. Dictionary is a collection of keys and values. We already have built in JavaScript now since ES 5 or 6, can't remember, the map, which is exactly that, a key value pair collection. So I don't think it would make much sense to implement my own key value pair. The dictionary generic class provides a mapping from a set of keys to a set of values. Each addition to the dictionary consists of a value and its associated key. Retrieving a value by using its key is very fast, close to O of 1, because the dictionary class is implemented as a hash table. Yeah, that's exactly what the map does. So I don't see a point in doing that. Hash set. Now, what is that? Represents a set of values. The type of elements in the hash set is in the following example. Remarks. The hash set class provides high-performance set operations. A set is a collection that contains no duplicate elements and whose elements are in no particular order. And we have that too in JavaScript built in now with the set. I wonder, it did say in no particular order. I think in JavaScript it's in order of that it was added to the set. In insertion order, right, when you iterate through it. But other than that, there's nothing special about the way it's ordered. All right, then, yeah, I don't I think there's the hashlay class is based on the model of mathematical sets and provides high performance set operations similar to accessing the keys. Yeah, that's pretty. Yeah, in simple terms, the hashlay class can be thought of as a dictionary collection without values. Yeah, that describes pretty well the JavaScript set, so I don't think there's any point in doing that for now anyways. We might want to augment the set with, you know, other methods at some point or something, but for now, okay, those are interfaces. What is that? Object key value pair. Don't know. Oh, it's probably used by the, like the map, the hash map, or whatever, dictionary. Linked list, I kind of decided I wasn't going to do one. I don't think it makes much sense in JavaScript. The array, the built-in array is, I think, usually much faster. So list, just a list, what is that? Represents a strongly typed list of objects that can be accessed by index, provides methods to search, sort, and manipulate lists. Basically the JavaScript array, so I don't think we're going to be implementing that. Q already did that. Now that's interesting, sorted dictionary. Let's take a look at this. Sorted dictionary. Represents a collection of key value pairs that are sorted on the key. Is a binary search tree. Ha. Okay. With O log n retrieval, where n is the number of elements in the dictionary. In this respect, it is similar to the sorted list generic class. The two classes have similar object models and both have O log n retrieval. Where the two classes differ is in memory use and speed of insertion and removal. Sorted list uses less memory than sorted dictionary. Sorted dictionary has faster insertion and removal operations for unsorted data. O log n as opposed to ON for sorted list. If the list is populated all at once from sorted data, sorted list is faster than sorted dictionary. It's populated all at once from sorted data. Each key value pair can be retrieved as a key value pair. Okay, that's the structure as a dictionary entry through the non-generic dictionary interface. Keys must be immutable as long as they are used as keys in the sorted dictionary. Right. Every key in a sorted dictionary must be unique. A key cannot be null, but a value can be, if the value type is a reference type. This could be interesting. So what caught my eye was the fact that it is a binary search tree. Now implementing that could be interesting and useful. So we might do it. But let's keep going. So sorted list is essentially the same thing from what I understand. A collection of key value pairs that are sorted by key. If I look at generic class is an array of key value pairs, O log n retrieval, oh, okay, so that's it, yeah. Basically the same thing, just the implementation is slightly different and the performance is different in different cases. And then sorted set. represents a collection of objects that is maintained in sorted order. So let's take a look at a sorted set object maintains a sorted order without affecting performance as the elements are inserted and deleted. Really? Duplicate elements are not allowed. Changing the sort values of existing items is not supported. Changing the sort values of existing items is not supported and may lead to unexpected behavior. So once you've added a value to the sort, an item to the sorted set, you can't mutate it? Is that what I'm to understand? So you would have to remove it, mutate it, put it back in, basically. I'm trying to think of the use case for this. Okay, we'll put that one on the back burner. So of all the collections left in the .NET library, the one I'm most interested in is probably like a sorted dictionary, which is basically a binary search tree. That could be interesting to implement. Let's take a look at the Java collection, see if they have something similar to that. Tree set, queue, row lists. Oh, they don't seem to have sorted anything. Enum set. Yep, let me just turn the alerts off. Like that. Okay. Well, there's tree set. What is that? Tree set. A navigable set. Implementation based on a tree map. The elements are ordered using their natural ordering or by comparator, provided a set creation time, depending on which constructor is used. This implementation provides guaranteed log-n time costs for the basic operations add remove contains. Note that the ordering maintained by a set. So it's basically like our ordered set, sorted set. That's exactly what it is, I think. Implements navigable set. Tree map. Oh, that's probably... Oh, interesting. It doesn't inherit from the collection at all. Doesn't implement the collection interface. It's the map, navigable map, sorted map, tree map. A red-black tree map, navigable map. Implementation. The map is sorted according to the natural ordering of its keys or by a comparator. Provides guaranteed blah blah blah. Note that the ordering maintained by a tree map, like any sorted map, and whether or not an explicit comparator is provided, must be consistent with equals. Blah 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 blah. So I think that is the equivalent. That's a key value pair kind of collection using a tree. Red black tree, I think that's another word for binary tree, right? Red black tree. A red-black tree is a kind of self-balancing binary search tree in computer science. Each node of binary tree has an extra bit, and that bit is often interpreted as the color, red or black, of the node. These color bits are used to ensure that the tree remains approximately balanced during insertion and deletions. All right, which is kind of important, I think. Balance is preserved by painting each node of the tree with one or two colors in a way that satisfies certain properties, which collectively constrain how unbalanced the tree can become in the worst case. Yeah, because if it gets unbalanced, your performance can get really bad if you get one side of the tree that gets really deep or wide. When a tree is modified, the new tree is subsequently rearranged and repainted to restore the coloring properties. Properties are designed in such a way that this rearranging and the recoloring can be performed efficiently. Uh-huh. All right, cool. Cool. You even have a nice little example here. Oh, is that pseudocode or is that actual C code? Yeah, C code is going to be. But okay. Interesting stuff. Put that aside for now. I don't think we're going to be needing this. So I think that's a good candidate. And you know what? I think, there you go. That's my little data structures for game programmers thing. And I was at the trees chapter. So maybe it's a good idea. Build a basic tree. Build a more complex tree. Building the tree class, the structure, tree iterator, vertical iterator functions, down function, building a tree, traversing a tree. Now that's just a normal, oh, well, look at that, binary trees. But it might be useful to have just a generic tree. Would that be useful? I think it could be. All right, because in a lot of the puzzles and exercises and katas and stuff like that, you have to use a tree data structure, or it makes sense anyways to use it, but not always a binary tree, right? Not always a binary search tree. I think, anyways. All right, I'm going to think about that. We're narrowing in on our next data structure to implement. Let's take a look at this guy's TypeScript collections library. So, this must be it, right? BS tree, binary search tree. So, okay, he implemented it. Bag. What's a bag? What's a bag? Creates an empty bag. A bag is a special kind of set in which members are allowed to appear more than once. Okay. What's the point of that? Well, I can see some. Well, you could just use an array, and like, why wouldn't you just use an array and not care about the indexes? Interesting. I don't see the point of that. Dictionary, we already said we have map. Factory dictionary. What's that? Factory to create default values. Creates an empty dictionary. This implementation accepts any kind of object as keys. The default factory function should return a new object of required type. If the keys are custom objects. It's basically to populate a dictionary, I think. Not sure. Okay, linked dictionary. This guy likes dictionaries. There's Heap. Oh, interesting. What's a heap? Array used to store the elements of the heap. Okay. Function used to compare elements. Create an empty heap. A heap is a binary tree where the nodes maintain the heap property. Each node is smaller than each of its children, and therefore a min heap. This implementation uses an array to store elements. If the inserted elements are custom objects, a compare function must be provided at construction time. Otherwise, the smaller than, triple equals, or bigger than operators are used to compare elements. I don't know about the heap data structure, but it seems to be implemented using some sort of a tree. Interesting. And now, just close my door here. A priority queue multi-dictionary. Creates an empty multi. A multi-dictionary is a special kind of dictionary that holds multiple values against each key. Setting value into the dictionary will add the value to an array of that key. Getting a key will return an array holding all the values set to that key. I don't see the point of doing that. You can easily do that yourself, if that's what you really wanted. You could, yeah, it would, well, no, I guess it would be simpler to have a class if that's, I have yet to see a use case for this, so. I can kind of, alright, I wouldn't call it a priority. I think the BS tree is more what we should go with. Yeah. All right, so let's go for the tree. Oh, this one too I wanted to look at. This is a nice little library with a lot of stuff in there. Sorted array set, sorted set, sorted map. Sorted array map, a map of key value pairs sorted by key backed by an array. A map with entries sorted by key. Interesting. Let's take a look at just the description of sorted. A sorted map is backed by a sorted set or key value entries with content equals and compare overridden to consider only the key. There's no other talk of the implementation, whether it's using an actual tree or some other trick. Sorted array map is a map backed by a sorted array set, which is in turn backed by a sorted array, backed by an array. The sorted array maintains the order of the entries using a binary search, considering only the key portion of each entry. So that would be similar to what we're trying to do. So let's take a look here. Let's get the binary search tree implementation here. BS tree. Special case of the binary search tree in which the search key is equal to the element type. This definition is suitable when the element type cannot be split between what defines its order and what does. Element type BS tree, BS tree, BS tree key value. Interesting. So this would be more the. Oh, I see. This is like more like a sorted set, right? You just have the, which makes sense, I guess, if you're just sorting strings and numbers. So, okay, so now I understand. Sorted set, sorted map. So I could potentially implement both. But the first step might be to implement a tree, just an abstract tree class maybe, or a base tree class that we could use. Add clear is empty, size contains, search, remove. Where does he keep? Where does he store? He uses nodes, okay. Node objects, apparently. Root is an object with this interface. Left child, right child, parent. Oh, so yeah. Oh yeah, because it's a binary tree, so there's only two of them. Private and elements. Mm-hmm. And what if would there be a point in having just an abstract tree? I'm wondering why, if we're looking at this guy here, and also the Java implementation is there talk of an array in here, or was it sorted dictionary? Let's go here. No, I think it was this guy here. It'd be interesting to look at the source code, see that's what we're gonna do. Oops, no. Let's open that in the new tab, yeah. See if we can understand what's going on in here. Equals, object equals, compare equals. Get default. Content equals. Values equals, compare, get defaults. Not much happening in here. Sorted array map. Calls basically the sorted array set. Haxo requires sorted array map. Sorted array map will work in Montage.js, whatever that is. But yeah, looks to me like it's built on top of the sorted array set, and I think that's what he's saying. Sorted is a map backed by sorted array set. So let's go look at the sorted array set to see how he implements that. Sorted array set. Sorted array set, which in turn is backed by sorted array, backed by an array. The array contains an order of entries using binary search. Where is that binary search happening though? Sorted array set. Reduce right. Reduce. All right, let's go look at sorted array. Sorted array. This array is array. This array equals values. is the array, okay. Otherwise an empty array, okay, so function search, okay. Var first, var last, while first is bigger than last. Var middle equals math.for. Comparison, if comparison. Not very easy to understand what's going on here. But I think all right, this might add search for insertion index. Search for insertion index. Var index equals search. Array value compare. If index is bigger than 0, return minus index minus 1. Else. Wow, this looks like a complicated implementation. So instead of having nodes and actually going through the entire tree of node objects, he uses an array, and he's got some way to use the index keys which I guess you could do if it's a binary search tree. If it's a binary search tree and you start the root at 0, then 1 would be left, 2 would be right, then 3 would be left of 1, and yeah, how would that work? I don't know. Okay, but the thing is, it's in terms of memory, that's a pretty nice way of doing it since you're using the array, so it's probably takes up a lot less memory. In terms of performance, would it necessarily be faster? I don't know. Possibly, since you're using contiguous memory. Okay, but this is more complicated in ways. Maybe not all that complicated, but if I want to start implementing something, maybe I should just start with the traditional model of using nodes, node objects. And then we'll test performance and see if we want to change that. So should we start with just an abstract tree? That's the question here. Build a basic tree. In this step, I want you to add 3 children to the root node. To do so, you must complete these commands. Go to root, click insert after 3 times. After you do this, you have to traverse the tree. Class tree. Class node. All right. I will call this tree TS for now. And now, do I want to? Now I wonder, the array has, like the point of having a sorted map. What's the point of having a sorted map or a sorted set, really? In a binary search tree it's to optimize for searching, right? I have my doubts that any implementation that I can make would be faster than the actual built-in map in JavaScript. But we'll never know without testing it. Because I'm pretty sure the built-in map in JavaScript is optimized for searching as well. Like, I don't know if under the hood they actually put it in a binary search tree kind of thing, but I have a feeling they might. So then I would end up, implementing this sorted tree for no good reason. Tough decision. I could do it for science. Actually, here's yeah, let's try to do a little test here. And we're going to use this guy's. Well, actually, we can use both. That would be interesting. All right, let's do that. Let's bring in both of these. So this guy is npm TypeScript collections. Let's bring that in. Oops, terminal. Yep. Okay, so let's bring this guy in, and don't need the save thing anymore. What's the other guys? Collections, npm install. That's just collections. Okay. Collections. Okay. Been added to my. Now I don't know if there is a typings for this dude. Let's see. npm install this types collections. Looks like there might be. Okay. Now, how are we going to do this? Let's bring in, how do we use this thing? Use by requiring each collection as needed. So, looks like they are default exports. So I could probably use the import, we're going to call this sorted, what do they call it? Sorted array map. Sorted array map. Sorted array map from collections. Interesting that there's, if I do this, from collections. Now, sorted array map is declared, but its value is never read. File, C, index is not a module. Is not? What? Then what is it? Probably need to do it from index, maybe. Not even. What if I use the old require syntax? Okay, let's try that. Oh, right. So maybe I do need to do collections sorted array map. No. What? All right, let's go in there. Sorted array map. That seems to be correct. Why don't you work? Yeah, it's being exported. So maybe it's the typing file that is worth crap. Collections, index.ts. Declare module collections sorted set. Okay. I think I see what's going on. This guy just needed the sorted set, so he went ahead and he did a types file, but only for what he needed. Very nice. Very nice. Jerk. So let's see. It means I'm going to have to declare module. Can I do it right in here, or do I have to do it in a separate file? Probably have to do it in a separate file, eh? Invalid module name and augmentation. Module collection sorted array maps resolves to an untyped module at which cannot be augmented. Interesting. So what if I was to do just sorted array map, sorted. Oh, I really don't feel like having to do this. So you know what? Here's what I'm gonna do. Forget about this. Forget about that for now. Let's just do temp.js. And now let's do that. We'll just do our test in JS, straight JS. Oh, but we want the sorted array map. So, sorted array map. Okay. File income JS module. It may be converted to an ES6 module. It may. Oh, okay. But I won't. Sorted array map. From length, blah, blah, blah. Okay, interesting. If I just do that, values equals, we compare. That's exactly what I did, didn't I? Yep. Let's just make this a const, okay. And then I create the, let's use Quokka to figure out what's going on here. Const, let's call this BS1, or let's just call it map1. Map1 equals this. Interesting. Okay. Probably pass in, let's make our initial array of values. So const values equal to this. And then it's just going to be other internal entries. Let's make this simple. We'll use just numbers and then strings. Yo. And then this will be 2. And then what's up? And then this will be 3. Actually, if I want to do a meaningful test here, I probably need to have like something that's pretty big. Damn. How am I gonna do this? I could. Generate something randomly, maybe. Entries. Alright, if I look the other one, can I feed it? Constructor. Looks like we can only that's going to be a pain. All right, so we'll test them both ways. Let's import it first. By doing ES6 import or JavaScript. Let's just use this for now. Looks like you have to import the entire thing. So that's what we'll do. Just a const TypeScript collections, and then go const map2 is equal to collections dot key value pair. Do I have to use the new? I think I have to use the new in this one. Like that. Yep. So now I believe we've got our map 1 and map 2. Yep. Okay. Now we need to add stuff to it. See how fast that is. And then, yeah, let's start by seeing how quick they are for, oh yeah, and also I also want to try and compare it to the actual built-in map. So, okay, const map 3 equals new map. There we go. Now, adding. We're just going to use a for loop. Let's make it relatively small for now. Equals 0. And we'll just make it I is smaller or equal to 1,000 to smaller to 1,000 I plus plus. Right, so we're going to generate, how do I generate random stuff here? Let's say I was going to do, but that wouldn't be a good test, would it? Crap. Because if I generate random stuff, how could I would have to generate my key value pairs ahead of time and use the same, okay, yeah, I can do that. All right, so we're gonna have an array called values. Is it gonna be an array? Yeah, it's gonna be an array. It's gonna be an array of values. We're gonna generate 1,000 one of them, and we don't really care about the value. We care about the key, because that's what's going to be used for sorting. Right? So let's use, but here again, that's the thing. if I was going to use logically, if I was going to use this, I wanted, like if I wanted something that was just sorted by number, I'd use an array. Or maybe not, because then it could be sparse. Yeah. Okay, so let's just do that. We're just going to use a number as the key. So math dot random returns a pseudo random number between 0 and 1. That's cool. We want it to be an integer though. Or do we? No, we don't care. We don't care. So let's just not care and push that to, well, let's multiply it by 10. So if it's between 0 and 1, it would be easier if we'd look at, if we'd make it integers, wouldn't it? Easier to read if I need to debug or look at something. And let's see, I always look this up because I only do this like once every few months, but JavaScript, random int integer, boom. Oh, they show a example of that straight in D. Look at that. Math.for. Can even get a. See, I don't know why this isn't in the standard library, honestly. But whatever. There we go. Get random int. The maximum is going to be 100. No, 1,000, 10,000, 100,000. How's that? 100,000. And we want to push that to our values. So values dot push. We're actually going to push an array, like a tuple. So this is the key, and the value we don't really care about. Let's make it just a string called this is of the value. Let's keep it like that. Okay. So now I have a let's take a look. There you go. Perfect. Now I want to test, basically take this. I have to test, so there's 1,000 of them. Yeah, we know that. I'm going to take my first map dot, how do I add stuff to it? Push. Let's just make sure that's the way he does it. Add. Adds value for a given key to a map. Nope. Yes. Yes. Does he also have push? That would be weird. Why is it showing me push as a... That's interesting. And it's not showing me add. Let's do a quick test here. Mat1 dot add. And what's the signature? It's okay, like that. Whoa, wait. He sets the value for a given key. Adds a value for a given key to a map. Alright, so we're going to use set key value. Yeah. So set. And the key is going to be 1. The value is going to be who cares? And now let's take a look at our map 1. Hello. That took a long time. Okay. I guess we won't find out that way. What if I did console.log? Would that be better? It would not. So let's do map.1.get 1. Not get default, just get. Who cares? Okay, good. So that worked. That is the correct thing to use. Map.set for this one anyways. So we're going to do that. Map1.set. Then you're going to take values I 0 and values I 1. Not store, set. Boom. And I should have a map1 of length 993. Okay. Because I've generated some. Yeah, that's cool. Not a problem. So let's do that for each one of them. But this time we'll do map2. Set is not a function. Okay, so what do you use, mister? You're sorted. Which one is it? This one. And we're using the binary search tree. KV, is that the one we're using? TypeScript collection, BS tree KV, yeah. So what am I supposed to use if not set? I'm supposed to use add, it looks like. I think so. Yep. So let's use add. There we go. And now if we look at map 2, 994 elements. Now that's interesting. If I do dot length, do you have that, or dot size? Yeah. Oh, it's a function, so let's do it. And now it says 994. And the other dude says dot length probably works here. Okay, they're both at 994. Good. So we got that right. Cool, cool, cool. And now for the actual map. Built-in JavaScript map, which is map 3, and then set. I do map 3 dot size. Ha! How interesting. This one gives me 1,000 because it's not using the value, it's actually using the reference as the key. Yeah. Very interesting. Which is a different behavior. So in other words, this one doesn't allow for duplication of keys. Key value anyways, and there's a certain logic to that. Well, this one does. If I wanted to... Not a big difference though, there's only 6 of them. Let's just pretend like I didn't see that. I'm not sure if that is right, looking for Amy. What do you mean? What are you not sure if it's right? The fact that the built-in map, the JavaScript built-in map, uses basically references for the keys instead of values. I'm pretty sure. Okay, so let's see. Well, that's interesting because I don't know how long you've been watching, but these 2 other implementations of map basically are showing. Yeah, so let me show you. So this is map 1. That I think they're using length. Let's see. Oh, that's interesting. What? Are you seeing this? Oh yeah. Oh no, that's normal because every time I make a change, I'm using like a little scratch pad kind of thing called Quokka, and so it kind of regenerates the random values. Okay. So in this case here, we're not getting any. Oh. Yeah, so that's probably, okay, let's do this. This might be, I see what's going on here. I think this was it here. Okay, yeah. Yeah, okay. So I think you're right. Because we are seeing the same. I just got thrown off because it kind of regenerated the values. Cool. Good. Much better. So if you just jumped in, what I'm building my own collection library, and I'm trying to determine whether it's worth it or not to make a sorted map using a binary search tree. Because my feeling is that the built-in map is really well optimized by the JavaScript engines, like V8, for instance, and that I not sure that rolling out my own BS tree implementation would actually, in terms of performance, make that much of a difference. So I'm using these two other guys as libraries. They have implemented sorted maps differently though, but still using kind of the binary search tree principle. So I'm curious to see if theirs is faster than the built-in. If it is, then it might be worth trying to implement my own. If not, I'm not going to bother, and that's that. So first step is I'm generating 1,000 key value pairs. I'm just keeping the value. I don't care about the value really. So this is the value, and I'm just generating random numbers for the key. All right, so now we've got, well, should we test that? I mean, we could test that for performance first, right? So how am I going to do this? I'm going to use, I should probably use like a, does console, is it time? Console time? Yeah, I think so. Console time, then you just put in the label, so that'll be map 1. Does that work in Node though? Or is it just in browser? Okay, what are you saying here? Const number of unique items equals values dot filter blah 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 set index of item values dot filter item index self. I don't even know what would that do? Let me just paste it in here so I can see it better. So filter index is equal to self dot index item. Self is the array itself, right? Item index, this should be the array index of. You can use it to figure out how many unique items there are in your generated array. I could. Okay, yeah, that's cool. That's a good idea. I don't know. Well, let's keep it there if I ever need to use it. So that should match the size of all the maps. Oh, okay. Do you suspect that there's something wrong in the way that it's generating them? Let's take a look, just for fun. You went through the trouble of writing this, we're going to use it. So number of unique items equals values dot filters item index. Wait, I can just probably do this, right? Because you've already, yeah, okay. This actually filters it, and I can just do dot length, right? I think so, yeah. No clue. Oh yeah, oh, add dot length, yeah, there you go. So 1,000, and I do that map dot map 1 dot length here. Ooh, interesting. We have a discrepancy. So index is equal to self dot index of. Well, I honestly don't really care. As long as, because I only want to compare the three, so as long as I know that they all have the same elements in there, which we've pretty much confirmed, I don't really care. So let's say I wanted to so yes, you are absolutely right before that it says that 1 foo is equal to 1 foo. Yeah. Console dot what is it? Time end or time end? Yeah. Is it? Because I don't know. right, look at this. So we've got our, this one here. Dot size, I think they're using. Okay, wait, you're saying that it's checking for value equality, or it's checking for it's by reference? It's not map size. What is it? Length? That one too, maybe? No, what is it? Map 2. That's my problem. Yep, size. Size. 993, and this map 3 is the built-in. So, which is size as well. See? But it isn't. Look. It's exactly the same as the other ones. So it doesn't do it by reference, it does it by value. Anyways, in terms of the primitives, since my key, it would be if my key was an object, for instance, then it would use reference equality, I guess. But when it's a primitive, like a string or a number, then obviously there won't be any duplication there. It's going to be by value, I think. Anyways, that's how I understand it, because clearly they all contain the same amount. I did generate 1,000 of them, and it drops 6 of them in each case. So that's cool. That's what we want, because we're trying to test performance, so we need to have them on equal footing. Yeah, that's right. Yeah. Okay, so let's just now, I probably shouldn't run this performance test inside of Quokka. I probably should, let's see, just run it node, yeah, I guess that's the best way to do this. So I'm in, where am I? Collections, source, temp.js. That should work, right? Boom, okay. 4.8419 milliseconds. That's not a huge test, but map 2. Wanted to do it with a relatively small one and then with a bigger one afterwards. So I didn't even know that console.time worked in Node as well. I thought you had to use like the performance hook or whatever it was called, performance.now or timers, or can't remember. They have like a special thing for that. So that's pretty cool. Oop, screwed that one up, didn't I? In that case, it should have been const. Hey, thanks for the follow, Queen City. In that case, it should have been const number of unique items. Oh, for your, yeah. All right. Okay, so here's a first. And I mean, that's to be expected. Oh, that's interesting. I would not have thought that. Okay. I thought that this implementation would have been faster than this one here. But there seems to be a big difference. In terms of adding, anyways, that's all we're testing right now. In terms of setting values to the map. But see how much faster the built-in is? It's crazy faster. Like at least one order of magnitude to this implementation, and like way more than this one. But that's just for adding, right? And you would expect these two implementations to be slower to add because they're supposed to be optimized for search, right? So that's cool. We're not going to worry about that for now. Now what I want to try is, okay, I should probably describe this a little bit better. So map one, let's call that set. I'm just going to add set here. That's what we're testing. Oops. And set. And just for, let's see. Looking for Amy says, and the API you were talking about is process.hrtime. And process.hrtime big. No, that's not what I was thinking about, although that might do. Let's see, Node.js. What I'm thinking about, where's docs here? I'm thinking about, there you go. This is what I'm thinking about. Performance. Performance.now or mark. Yeah, performance.mark. And measure, I think, or something like that. It's supposed to be really precise, but actually now that I'm here, let's look at what they're saying about time. Starts timer that can be used to compute the duration of an operation. Timers are identified, blah, 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 use the label, oh, okay. An output to elapsed time in milliseconds to timer durations are accurate to sub-millisecond, so good enough for me. That's awesome. Because one of the problems I think in the browser with using something like, date.now, or even now I think they have performance.now in the browser as well. But because of some security flaw, it's basically not that accurate. I mean, for long-running tasks, it'll be fine. But if you're trying to, look at something that's just like a few milliseconds or even under a millisecond, then you can't trust it. But this one says it's sub-millisecond accurate, so and it's a simple API to use, right? When you just want to write a few performance tests like this. Today you learned something. Good, great. That's awesome. I learned a lot of stuff doing this too. All right, let's test. Well, the one thing we're really interested in is the search, right? Because it's supposed to be optimized. These two, map 1, map 2, are supposed to be optimized for searching. That's the purpose of the binary search tree for retrieving. So let's test that. Let's test a bunch of gets. I guess. Now, hold on. Let's separate this a little bit. We're just going to use this for set, and this is going to be get. Okay. Oh, now I need to change this by hand. No. Okay. And how am I going to structure this? I have to get an actual... Oh, I can just go through the entire... Yeah, let's do that. Map1.get values, and that's all I care about. I just care about this. I don't know if that's the right API though for this For people interested in that security thing you just talked about, the security change came with Spectre Meltdown. That's right, yeah. Changed the browser resolution from performance.now to 1 millisecond, which isn't, it's not the end of the world. When you're testing for stuff that's, takes more than 1 millisecond. But it's good to know that in Node, it's still sub-millisecond precision. I just need to check what the API is for this. It probably is get. It's usually what it is, right? For maps. I don't see it though. Oh yeah, right here, get, good. So it's get for all of them, I'm pretty sure. Let's take this, look at this one. Oh no, I think this one was using add. Is that what it was? Let's see. What was it using? Yeah, it was using add. So what is the equivalent of get in here? Add, clear is empty, size, contains, search. Looks for the value with the provided search key. So it would be search. And it returns the value. Okay. Search. Interesting choice of API there. So search. And I know that the built-in one is get. Just need to do this like that. For browser testing, it's just fine, methinks. Yeah, me too. The add one has search. That's correct. Cool. Glad you're following along. Okay, and that's right. That's right. Okay, I think we've got this. Right, I'm using the right one. Map 1, map 2, map 3, map 1, map 2, map 3. Good. I didn't touch this, so this is fine. Let's do it. All right, so again, and here's my proof, I guess. The get is much faster than the get for these other ones. It confirms the feeling I had that V8, which is the main JavaScript engine on browsers and in Node, optimizes the out of map. Right? They probably even have their own like C++ implementation of a kind of a binary search tree underneath it. And there's not much we can do in JavaScript itself to beat the performance of that, is what I'm thinking. There is one thing we could try, though. Because oftentimes I've realized that the JavaScript engines do optimize for a bunch of stuff, like the array too. It's super, like it used to be that people were like, oh, you should use a linked list if you want to implement a queue in JavaScript, because if you use an array, unshift and shift is super slow and blah blah. But you know what? They've in the past few years, V8 at least, and I'm pretty sure the other vendors followed suit. They've optimized that, and shift and unshift it's pretty much constant time now for relatively small arrays, and that's the thing. When you get into like really big arrays, then you might hit a problem. But I mean, realistically, how often are you going to use an array of like a billion items? So let's test that out. Let's make this really big. I should have been smart about this, and instead of hard coding this in. See, that's why you're not supposed to use magic numbers. All right, let's do that. Const items. Number of items. Number of items. Let's make it 100,000. Put that in there. That way we only have to change it in one place. The dangers of copy paste. Okay. It's going to take a little longer to run, obviously. Okay, quite a bit longer to run. Much longer to run. Okay. Wow. That's interesting. Oh, I'm just going to stop my quokka just in case it kind of messes with the... Okay. What are we seeing here? Well, that's interesting. Now we're seeing that the first implementation here is crazy slow to add. Like really much slower. Is this too small? Can you see this on the screen? Do you want me to... Should I zoom in or something? Or there you go. Maybe this would be better for you guys. So wow, this is like, what is going on here? But the interesting thing here, I find, is that whereas we had like an order of magnitude faster, the map, the built-in map was an order of magnitude faster in the smaller test, right? About 10 times faster. Now, in this test, it's maybe like a bit more than twice. So as we're growing in size, for some reason, adding gets proportionally faster in this implementation. Interesting. Now, in terms of getting, we're still a lot faster. What was it before? It was not quite 10 times as fast. It was 10 times, more than 10 times as fast for map 1 versus map 3. Not quite 10 times as fast for map 2 versus map 3. And now we're still quite a bit faster. So let's go crazy. See if we can get big enough where the built-in map optimizations will disappear and these other guys might take the lead. So we're at a million items. Let's do this. This might take a little while. Wait. In the meantime, looking for Amy. Where are you from? And also, have you found Amy? Or are you still looking? Waiting. The Netherlands, cool. Cool. Are you in one of the big cities like Amsterdam or what's the other one? Rotterdam? I think my boyfriend decided to name himself actually Amy. That's funny. That is funny. Oh, wait. Are you Sleepless Bites? Or are you someone else? Oh, this is done. I wasn't paying attention. Oh yeah, okay. Cool. It's just that you're using a different handle in Twitch. Okay. I just made the connection because you said you were from the Netherlands. All right. So what do we have here? We're still faster. Oh no, we're still running. I thought we were done, but we're still running. Crap. Big latency between chat and video now, huh? Maybe because of this long running task. But I don't think so. I think I have enough cores to handle this. Anyways, this is just a one thread. Wow, I didn't think it was going to take that much longer. But all I did was add 1 0. Come on. Exponential. Oh, right. I should have thought about that. Crap. Look, because these guys aren't so bad, but this one, oh man. How much longer is this going to take? So here's the thing. Even if the BAP1 implementation ends up for 1,000,000 items being faster for the get, um, it's so long to actually set that we could probably take it out of the running. Although if it's just one item at a time, because well, no, that's not true, right? Oh, exciting stuff. The results are in. Yeah, thankfully we're not exactly O of n. It didn't take 12 minutes. Yeah, I'm French Canadian. That is correct. I'm from Quebec. I am in the Montreal area. All right, so with 1,000,000 items, we're still much faster, both in the set and the get with the built-in map. Is there anything else I should test before we conclude that it's not worth implementing a sorted map whoa, I think I went too small there. Let's just, okay. Actually, let's leave it there. Yeah, look at the magnitude difference. I think it actually, am I wrong in I think it actually gets even better, right? I think our performance difference got better in favor of our built-in map as the items grew. It grew, yeah, that's right. It might be worth implementing in C, but not in JS. Yeah, exactly. But right now I'm building my own TypeScript collections library, and I don't want to implement stuff just for the sake of implementing them if there's no point. Like I've implemented queue and stack using, and they're backed by the built-in array. And the reason I bothered with that is because the thing with and tell me what you think about this, actually, I'm interested in your opinion, but um, the JavaScript array is super versatile, and I love it. It's great, and it's been super optimized too with the V8 engine and others. But it's got a super wide API, right? So if you want to use an array only as a stack, and it's really important for your program that array is only being used as a stack. Well, if you pass that array around, which you probably shouldn't be doing anyways, right? You should be passing iterators, but whatever. Then it gives other places in your code the opportunity to start using all kinds of other methods on the array, right? And not use it as a stack, or if you pass it to a client or whatever, right? If it's a public API, well, then you really shouldn't give the array. But you know what I mean, right? So by implementing your own class, you're restricting the API to just what you want to use. So that's what I'm doing. Peek, pop, push, and that's it. And the same with Q, right? I kept the API really simple and made sure to implement the symbol dot iterator, right? So that you can use a for of loop with it. So that was my thinking. In terms of performance, it's backed by the array, so there's like just a little bit of overhead because I'm using a class on top of it. But in terms of actually getting and setting and stuff like that, it shouldn't be a problem. So now I'm looking to add more data structures to my collection. Yes, I completely agree, says Looking for Amy, with your decision. There is another thing you should think about. By restricting this API via a class like this, if ever V8 has optimized versions of Q or stack, you can drop in and replace it or forward the calls. And then you're golden because no code needs to change outside of the class. That is very, very true. That is one of the benefits. And that's actually what I'm doing, really. Like, oh, it has optimized versions of Q. Oh, yeah, like if they were ever to come out with a built-in Q or built-in stack is what you mean? Yeah. Don't know if they ever will do that, but well, they did add map and set. All right, so now my big question is what other type of collection or data structure should I add to my library? I was thinking that maybe a binary search tree was a good idea, but then I thought all of a sudden, wait a minute, the set and the map are probably already optimized for that, and that's just been proven, so not gonna bother with it. So what else? What else could I do that would be useful and would make sense? I'm taking inspiration from the C#. You barely ever need a binary search tree. Yeah. But I've been doing a lot of puzzles and katas and stuff like that, and so I've been needing some less common data structures, graphs and things like that, but whatever. So stack I've got, sorted set, we've already determined that it's not worth doing. Sorted dictionary, sorted list, which is basically the sorted map. Don't need Q, already have it. List, that's kind of like an array in JavaScript. Linked list, not worth it. Set already built in. Dictionary, that's like a map already built in. Hash set, same thing. Dictionary, same thing. So in terms of the .NET, I think we've pretty much implemented everything that made sense in JavaScript. I don't think I can gain much more inspiration from this. I was looking also at the Java, which has a lot more data structures. The sorted map too they have. Let's see if I can get to sorted X is nice to have for some problems, not from an efficiency standpoint, but from always having a sorted iteration without needing to call .sort. It could just be an array set that you sort on add get. Yeah, that's true. But I mean, how hard is it to roll that yourself? Like if you do really need that for that one problem that comes up once in a blue moon, it's like super easy to do. Array.sort, boom, you're done. Right? Like, yeah, I get the convenience factor, but I want to keep my library kind of lean. I don't know, maybe like if I make this, I'll probably eventually put that up on NPM, and if I start getting a lot of requests for a certain type of collection, I might implement it. But for now, oh, I would be curious. Since we're in performance testing mode, it'd be interesting to, I don't have time to, yeah, to test my queue and stack implementation against these guys and the built-in, just using the straight built-in array. Might do that some other time, but for now, how about I try to figure out what's the next kind of data structure I can implement that would be very useful. So let's look at what Java has in its collection. That's the interface. What actually implements the interface? Abstract. That's what I did. Oh, there's another thing I might want to get your input on. Bit field, bit array. Yeah, I thought about this one. I skipped it, but minimax tree. Yeah, that's cool. I've done that a few times. Adjacency matrix. An adjacency matrix is basically like a graph, right? It's just a different way to represent a graph instead of using nodes. Am I right? Yeah. So instead of having an adjacency list, you have an adjacency matrix, which would be like a 2D array, I think. Oh, what is that? Let's take a look at this. Oh, that's the adjacency matrix. That's right. Yeah. I seem to remember reading when I was reading about graphs a few weeks ago, or it might have been months, that generally speaking, you're probably, in terms of general use cases, you're probably better using just an adjacency list instead of a matrix. I don't remember why exactly. I think it's because of all the sparse, of all the sparseness, I think. But might be wrong. State machine as a data structure is nice too. All right, so how would you implement that? Would you use like the state design pattern for that, or for a large sparse graph, adjacency lists require less storage space because they do not waste any space to represent edges that are not present. That's correct. Yeah. I think that's what it was saying. Implementing a state machine as a data structure. That could be interesting. And that could be very useful actually for some of the puzzles and stuff I'm working on often these days. So that I might think about that. But you're getting into pretty specific or more complex data structures. I want to make sure I cover the more basic ones first. Oh, how about a hash? No, not a hash, sorry, I mean a heap. I was reading about that the other day. I'm not too familiar though with it. What exactly does the heap set or heap tree? Heap tree, is that what it is? Heap data structure, just a heap. Okay. Computer science, a heap is a specialized tree-based data structure which is essentially an almost complete tree that satisfies the heap property. What is a heap? What is the heap property? Oh, like the biggest. It's a kind of binary tree then? Is that one of my? Heaps are usually implemented in an array, fixed size or dynamic array, so that's perfect for JavaScript, right? Do not require pointers between elements. After an element is inserted into or deleted from a heap, the heap property may be violated and the heap must be balanced by internal operations. That's cool. We can deal with that. Binary heaps may be represented in a very space-efficient way as an implicit data structure using an array alone. In which the tree is a binary tree, and we've just established that rolling out our own binary tree compared to the set or the map built into JavaScript in terms of performance is not really useful. So what would be the point? So what's the use case for a heap? What's it used for usually? The two next element of the array contains its children. Notably, insertion is often done by adding the new element at the end of the heap in the first available free space. This will generally violate the heap property, and so the elements are then sifted up until the heap property has been reestablished. Similarly, deleting the root is done by removing the root. Okay, I'm reading this and I'm not seeing a difference between a binary tree, like a binary search tree, and a heap. Priority queues. Oh yeah, that would make sense, right? Because it always bubbles up to the, yeah. Binary tree equals implementation heap equals abstract. Order statistics is cool with heaps. So I think I'm gonna have to read up a little bit more about it. I'm not familiar with it enough to see the nuance. Fibonacci, pairing, Brodo. So find the kth smallest or largest element. Right. But again, what if you just put in an array, sort the array, and just reach for the index, right? Like, put everything in an array, sort it, so array.sort. Then you want the fifth biggest one, so index 5. Boom, you're done. That's how you do it. Okay, so it's just okay. Just to have a nice API on top of that, I'm guessing. That could be worth implementing. That's worth thinking about. Oh yeah, I also have this really cool book. I don't know if you've ever heard of it. It's called what's it called? Data Structures for Game Programmers, I think. Hold on. It's kind of old. Yeah, Data Structures for Game Programmers. It's like at least 20 years old. Oh no, not quite. Roughly 20 years old, 15 to 20 years old. But it's kind of nice. And see, you were talking about bit arrays, I think, early on, or what was it? You had suggested bit fields or bit arrays, yeah. And I think he talks about them. But I was thinking, like, in JavaScript, does it make sense? Like, what do you have to gain to do that? To use something like that in JavaScript? You use them all the time, really? Oh, but not in JavaScript, right? You just use it for compact storage. For compact storage or data transfer? Would that make sense too? Like if you had a lot of data to transfer over the wire, maybe you could improve performance by making sure it's really packed. But in JavaScript, same as compactor. Yeah, you're right. Same thing, you're right. Okay, but in JS though, if I wanted to implement that, yeah, masking does, I get that. Masking makes it easy to do some operations, but really you don't need it. Yeah. Like if I was going to implement, like a chess engine, I could think about doing that. But for everything else, I'm like, yeah, that's right. It is doable, I know. I've done it too. Like what's the thing I did with that? I implemented, oh yeah, a while back I did this Monte Carlo tree search algorithm, um, and it can be used with pretty much any two-player deterministic game like chess, tic-tac-toe, checkers, things like that. But it's much more efficient if when you're implementing your the game state, if you use some kind of um, a bit map, I guess. Yeah, a bit map is what you call it, and use bit operations. It's more efficient if you do it that way. And so I ended up, I think it was tic-tac-toe, or maybe not tic-tac-toe, but some other game using that. That was fun. Might be nice if you have a bit field to use it to store option flags, but then again, why not have an object with fields that are true or false? Yes, 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 yes. Yeah, that's kind of what I was thinking. That's the thing, right? I'm trying to think for JavaScript of not fighting the language, because there's all these data structures out there, and some of them are specialized, and you know, they'll be worth using in a very specific case, or they'll be better for inserting at the end or at the front or whatever. And that's true with like a closer to the metal implementation. But in JavaScript, if you were to implement them yourself using like nodes or objects, or even like a linked list, then they end up being slower than using the built-in array or map or set or whatever. So it's rarely a good idea, I find, in JavaScript. We usually need these data structures because we don't have good high-level abstractions that are fast and efficient. In JS, array, map, set, and object are super optimized. That's right. So the need for most of these just falls away. Correct. You're pretty much left with only the having an easy to use or easier to use API instead of having the bag of fun that the array is. And yeah, so that's pretty much why I started with the stack and the queue, because I thought it made sense. I think those are pretty much, they're used a lot, right? And I'm not killing performance by just basically wrapping over the array. I just have a nicer API. But now I'm kind of like, what's next? Is my library just going to be queue and stack and that's it? Maybe. Oh, circular array. Like a buffer is like a circular buffer. Is that what that is? Or even like a circular queue? Is that or is that called a double-ended queue? Or can't remember. A bit confused between all of those. Stuff like that is nice to have, but easy to roll. Yeah, I might look into that. There is just no first or last item. There's no first or last item. After index n-1, it goes to 0. Right, just goes around. That's right. That's right. And where do you insert? Oh, right. So the size varies. You would modulo the index for any operation to the length. Right. Gotcha. Yeah, that could be interesting because I can see that being useful in certain cases. I'm gonna have to think about this. Yeah. All right. Well, my time's up. I'm gonna have to think on that, what I'm going to implement next in my library. That's going to be both useful and not overkill, you know. Abstraction on top of string. Now that's interesting. I didn't think about that. That's a very good idea. String manipulation in JavaScript is a bit of a pain sometimes. I often find myself saying like, why isn't there a built-in method for this? Right? Code points, graph memes, and then doing operation on it. String to code points or graph memes and then doing operation on it. Implementing ciphers is easy, but not straightforward. That's a good point. And there is a cipher puzzle I was going to do soon, so that could be really interesting. I could do the puzzle and then see where the pain points are, and I could build my own data structure that would make this easier. All right, well, that's food for thought. So, all right, I have to go, but this was fun. Thanks for sticking around and for your tips. Really appreciate it. See you around.